Hello, everyone, and welcome to today's webinar on how 3D scanning can solve productivity issues. My name is Jérôme Alexandre Lavoie, and I am the product manager for Creaform Quality Control Products. Today, with my colleagues Olivier Plamondon and Kyle Shannon, we will discuss how to choose between handheld or automated 3D scanning to solve productivity issues, including a live demonstration of our automated quality control solution. Before we get started, here are a few housekeeping notes. You can ask questions during the presentation in the question tab of your GoToWebinar control panel. We will do our best to answer all of your questions in the Q&A session at the end of the webinar. All right, let's get started. There are usually three different root causes for productivity issues experienced by manufacturing companies. Reduced productivity caused by complexity challenges refers to the extra time required to measure parts with complex three-dimensional shapes, parts with various surface finish, or both. Productivity issues can also come from slow measuring speed of the equipment used, or in other cases, from the lack of employee to run a measuring machine. Looking at different traditional measuring methods, we can conclude that they all require human operation to complete the measurement. There are different reasons why automation could make sense for a specific application. For example, you can improve a company productivity by removing human impact and subjectivity in the measurement results, leading to better decision faster, or by finding defects earlier and improving workflows to reduce scrap, rework, and waste. However, not all manual processes necessarily need automation to solve productivity issue. If a company is currently measuring parts manually with conventional tools, starting to use 3D scanning solutions will provide a significant improvement to solve productivity issues. The rise of portable 3D scanners in the recent years is explainable to their great combination of accuracy, speed, and simplicity. 3D scanning provides quality control with more data, more details, more information, which allows for inspection of more complex parts. Consequently, today's industry's experts now place their trust in 3D scanning and grant it a major role in quality control. Olivier has pre-recorded a short video to show how easy to use our portable 3D scanners on various part and surface finish. Be careful as the window may pop up behind your GoToWebinar current window.
Hi everyone, my name is Oliver and I'm an application specialist. Today I'm going to show you how easy it is to scan any kinds of materials with this portable 3D scanner. So here we have a manifold casting, and as you can see we have some shiny areas and more matte areas. So I'm just going to launch the lasers. And as you can see, it easily grabs onto the matte areas. I'm going to switch to the more shiny. And very quickly we can capture the shiny data without changing any parameters whatsoever. So here we have this black plastic manifold and its surface is really dark. Let's try it. As you can see, I can easily capture the surface without any part preparation whatsoever. Finally, we have a jet engine enclosure that has 3 different kinds of finishes. Let's start scanning. So once again, whether it's white, shiny, or matte, I can scan the whole part using one single configuration.
Okay. Thank you, Olivier. So in case where a customer is already using a portable 3D scanning or a CMM and still experience productivity issues, it might be worth it to consider a 3D scanning CMM. 3D scanning CMM, sorry, can be described as 3D scanning technology mounted on robots. By combining all the benefits of automation with the speed of 3D scanning technologies, value can be created for CMM, portable CMM, and 3D scanner users struggling with productivity. This seems good on paper, but in reality, quality control professionals are sometimes reluctant to deploy an automated quality control system. In fact, when asked what primarily prevented them from deploying an automated quality control system, 39% of the respondents said that it was a lack of employees with skills in robotics, while 36% said that it was the expensive price and lack of automation information about the return on investment. So for 75% of the people, it's either a question of experience with robots or ROI. We will discuss both subjects in the following slides. Before we get there, we will go ahead with our first poll of the day. So question number 1 is, how likely are you to start first with handheld 3D scanning prior of adopting automated 3D scanning? Are you not likely to do so and start right away with automation? Are you somewhat likely? Are you likely or very likely to experience the 3D scanning with handheld devices first before thinking of automation? I'm going to give you a few seconds, few seconds to complete the polls. We have the results that are coming in. I have a good idea that should look pretty much towards the likely and very likely. That's what we're seeing right now, 52%. And if you had a 33%, that's 85% that of the respondent now of you guys that are likely or very likely to start first with handheld and then move to automation. This is what I anticipated, but it's quite interesting to see it. Now, let's go back to the lack of experience in robotic factor, and let me show you how simple it actually is to work with an automated quality control solution. To do so, I will demonstrate using VxScanner a complete process from start to finish. VxScanner is Creaform simulation and scanning module for automated quality control. This is a software designed to make automated quality control accessible to non-expert in robotic, 3D scanning, or with Creaform technology. So I'm going to switch to the software demonstration first. I'm going to turn my computer so you can see me in action. I'm going to go to the next computer here. Yes. And what we're going to do, we're going to switch presenter mode, and you're going to be able to see what's happening in the software first. And there you go. You should be able to see what's going on right now. So right now we are in VxScan R. We have this setup right here. We got a robot, we got a turntable, you got the basically the Q-bar environment. I'm going to hide things so we have more room to look at stuff. So, and if I turn on, I have a webcam as well. You should be able to see it right now. Yes. So we have the setup in live. So once I start scanning, you'll see the part moving, and you'll see the metro scan going over the surfaces. So coming back to the complete process, inside VxScanner, the philosophy is very simple. You tell us what you want to scan. So I'm just going to zoom in on the CAD model right here, and we're going to start programming the robot. There are 4 ways to program the robot inside VxScanner. You can pick first surfaces like this one, and you got different options. You can manage the speed automatically based on the scanning resolution. You can go high speed, you can go high density. It will, and the robot speed will change depending on the scanning resolution. You can add some overshoot, meaning you're going to start before the surfaces and finish after the surfaces you want to scan. So let's do that. We're going to create a first robot path here. We're going to do the same thing on the other side. Now that's for how you pick surfaces. Now you can also come up here, and sometimes it's nice to follow some edges. So you can pick some edges here, for example, and enter, let's say, minus 45 degrees, and well, ask the software to follow that edge with a nice angle of attack. So you can do that, do this, and again, here and here. So we're going to follow that edge. In this case, we don't necessarily need some overshoot. So we're just going to do that here. I'm going to do the same thing on the other side. So I'm just going to really quickly pick some edges. I'm going to go 45 degrees. Yep. And there you go. And that's how it's done. Now, the third method to create a path in VxScanner is even more simpler than that. All you have to do is create a polyline. So you're just gonna come up and click some points here, here and there, and you're gonna see the path that is being created, and you can finish like that very simply to go and capture all of those pockets inside very nicely. That's the third method to create a robot path. And the last method to create it, it will be to simply jog the robot. You can click on the surface, yes, but after that, it's all manual process. You're just gonna, click select some area, click on the space bar to add some point and do stuff like that. You can go up, go down, you can change the angle. I'm not gonna save that because, to be honest, we have more than enough scanning sweeps right now to cover the entire surfaces of the part that we have today. So at this point right now, what we have is a robotic path that is not optimized at all. We have just asked to roughly create some robotic paths, but we need to optimize it. You need to remove all of the collisions. You need to make sure we don't go through any singularity. You wanna have maybe a reordering operation where you wanna not necessarily follow the order of creation, but more focused on, well, let's give me the path that's gonna have the shortest cycle time for the entire process. So this is what's happening right now. You let the software calculate everything for you. It's kind of a black magic box, but you let it go through that process. Sometimes it takes a little bit of time, but it's well worth it because you don't have to be an expert with the robotic side of it. You just let the software calculate, and once this step is done, you will have a robotic path that is optimized for the scanning parameters. You will have a robotic path that is optimized for cycle time, a robotic path that is not only free of collision, but has look for collision avoidance. You will have a robotic path that is also free of singularity. So really all the stuff that, sometimes takes a lot of time to adjust with a teach pendant, now you don't have to do that. Next up, now everything is green, that's good. Next up is to launch the scanning simulation. Because we're a little bit constrained on time, I'm just gonna accelerate the simulation, but you can see that the turntable is turning, the robot is going over all of the sweeps we have created, and you can simulate really your process. But I'm going fast because what I really want to do with you guys today is not necessarily go through a deep dive of the offline programming interface, but connect the robot. I'm just connecting to the robot right now. You're gonna hear potentially the robot controller starting to make some noise. Now, all I have to do is hit start scan. Before I do that, I'm just gonna hide the CAD model so you can see the real data acquisition. The scan is starting. You should see it on the webcam as well. Right now, nothing is moving. It's normal because I'm at 1%. I can change the robot speed like that. I'm going to hit 100% here. Here we go. So we're scanning the robot right now. You can see the laser lines projected on the surface. You can see the real-time surface reconstruction. It's not more complicated than that, okay? All we have done is we went through the software, we picked some surfaces, we've picked some edges, we have created some polylines, and now we have a robotic path that is, you know, being executed. After this step, I would have my part completely scanned. As you can see, we're going over surfaces that were already scanned. Like I said, I just wanted to show you how to program, but I think we could actually in real life do a program that would be much more faster than that. But what we're ending up with is a scan data of my part that is, you know, completely done. I just need to finalize it. And after that, you know, once I have my scan finalized, I guess the next logical step will be to, you know, inspect it. So I can just send it to an inspection software, get a color map, create some annotations, stuff like that. I can potentially, you know, modify the color scale just to see some colors appearing a little bit like 0.5 here, and we're gonna go 0.125, and there you go. You can start to see some deviation, stuff like that. That's it. It's not more complicated than that. We went through the part programming. We went through the actual optimization, and we went through the scan and the inspection. We're going to switch back the presenter now and continue with the slides for the rest of the presentation. Here we go. So you should be able to see my slides right now. We've talked about VXScanner. Yeah, like I said, after you have acquired the data, you can work with basically the metrology software that you want to perform the inspection. I just done it with VX Inspect, Creaform proprietary dimensional inspection software. But if you're more comfortable in Polyworks, that's not a problem at all. I could have sent the data to Polyworks directly. If you're more comfortable with Metrologic X4, it's also possible. Now, that is for how simple it is to work with an automated quality control solution. Now, let's go and tackle the second preventing factor from deploying automation, which is the price point and the ROI. Sorry. To cover this section, I have met with Kyle prior to this meeting, and here is what we have recorded.
Thank you. My name is Kyle Shannon. I'm the AQC Business Development Manager for North America. I would like to talk a little today about the cost associated with an AQC solution and the ROI of such a project. To start off, let's consider why automation. In general, there are 4 driving factors to implement automation in a manufacturing environment. Those typically are to reduce costs, increase operational efficiency, safety and ergonomics, and labor challenges. To dig deeper into automation dealing specifically with quality control, Creaform recently took a poll of various customers. In this chart, there were 4 main buckets or reasons that our customers were considering automation. Overwhelmingly, 82% of people in the poll want to automate in order to find defects earlier without human errors. So once you've identified your reason to automate, that leads us to the first challenge that gets brought up, which is usually price. Is automating my process going to be too expensive? Previously, Jerome identified that 36% of our users view price as a roadblock to automation, and is usually one of the first questions our customers ask us about when we are discussing AQC projects. While such a large capital expense may be hard to accept at first, it's industry proven that manufacturers see an average ROI of 24 months or less from robotic automation. This ROI may not be so straightforward though. Evaluating the financial benefits of automation require you to consider a variety of factors. Cost considerations go beyond simply comparing the equipment cost to hourly wages of a worker. To arrive at a true ROI, it is necessary to not only compare the robot cost to that of an operator, but also many other business costs and higher profit potential that may arise. The first step to analyzing a potential automation project is knowing your current costs and your situation. Then you want to compare those to the cost of implementing the new solution. Listed here are some of the key things you should consider in order to know the true cost of ownership. Firstly is labor costs. This one's pretty straightforward, but what is the fully burdened labor rate of your existing labor requirements to complete the process manually? Next, you want to look at your cycle times. You should document a good baseline of the existing process in order to accurately compare that to the new proposed system down the road. Also look at your scrap rates. Does your current system lead to quality errors and/or returns from your customers? Downtime and reduced capacity. This is oftentimes overlooked and can be attributed to various reasons such as employee shortages, changeovers, etc. It's also fair to analyze downtime during implementing and startup of a new proposed system as well. Training and staff development to work with the new system may be required. This may add more front-end costs on a new system, but there will be longer-term payoffs in the future. Also, you may realize some reduced management and/or human resource costs when managing a robot solution versus employees. Beyond just comparing costs, you need to also quantify and consider any improvements that your automating project might bring. First of those is quality improvements. As mentioned before, 82% of the people we talk to want to automate to find defects earlier. Will your quality improvements lead to less scrap rate or decreased costs? Do you have returns from your customers or warranty costs in the field that could also decrease? This is often not considered when analyzing an ROI, but oftentimes an improved automated QC system can help reduce those costs. Some automation initiatives are successful in increasing quality so much that they improve the output significantly. This means less quality control, fewer returns, less damage. Also, increased throughput. So you have to ask, what is the value to your company in increased revenue to be able to produce more parts? If this can be quantified, it almost always makes the ROI successful. Don't be afraid to challenge your internal team by adding this to any ROI calculations you may be considering. You should also consider if you now have reclaimed space or potentially lost space after implementing your automation project. Do you now have more room to add in additional resources to further improve production? And lastly, ergonomics and safety should always be considered. According to the National Safety Council, a single medically consulted injury costs over $39,000 to an employer. Automation should help reduce those injuries and the potential for them, and that should be baked into your calculations as well. In many other cases, automation can reduce the kind of tasks that result in stress injuries. Reducing the EMR rates and worker compensation potential are fair numbers to discuss with your company in your analysis as well. And then lastly, you want to look at labor challenges. It's no secret that in many areas the qualified workforce is shrinking. Labor shortages are major challenges you may be facing today that automation can help with. According to an article in Reliable Plant magazine, U.S. manufacturers will face a need for 3.5 million new jobs for the next 10 years, and they won't be able to fill almost 2 million of those. Being able to repurpose your existing workforce to value-added tasks and automate some of the more repeatable tasks can help alleviate those issues. This also helps reduce onboarding and labor acquisition costs. So lastly, when we're looking at the ROI and payback period, we must weigh all factors discussed when analyzing your project's specific ROI. There may even be some factors to your project we haven't identified today that are important for you as well. In general, in manufacturing, we have found that 2 years or less is an acceptable payback period for automation projects, and that is very achievable with solution from Creaform. If you can also repurpose for additional products or future programs, there are substantial future cost avoidances to try and quantify as well in your ROI. Luckily, with our VxScanR software and flexibility, it is very easy for Creaform or the user to add additional items for inspection in the future. So with that, I would like to wrap up my part of the presentation today and hand this back over to Jerome. Thank you very much.
Okay. Thank you, Kyle. And as you could see, experience in robotic is not required to deploy and operate an automated quality control solution. And when you are doing an ROI calculation, it's important to consider multiple factors. So we're going to go ahead with and show you a real customer example right after our second poll of the day. And the question this time is, how likely are you to pay for a feasibility slash validation study, including cell design, process simulation, build of material prior deploying an automated quality control solution? Are you not likely or not interested by such study? You'll do your own homeworks. Are you somewhat likely to do so? Are you likely or very likely to take maybe 5%, 10% of the total cost of a project and invest it in a small study to de-risk the entire operation for your company? So the results are still coming in. We're gonna cut it out in a few seconds. So earlier I think we've seen results that were very polarized, so split in different sections. Here this time it's wow, it's well split over the first three options. Quite interesting and also very different than what we've seen with our previous session for the European market. Interesting. Speaking of interesting, we're gonna, as promised, show you this customer example, a customer who have decided to implement the QBAR Creaform Turnkey 3D Scanning CMM. I want to warn you first, the volume on this video is quite high, so be careful. I mean, be aware that it's gonna come out pretty loud. I'm sorry for that. We've tried everything we could to reduce that, but it's out of our control for now. And there you go.
We realized that trend towards automation was unavoidable, and we wanted to quickly analyze our castings, and Creaform supplied with the best solution with a QBAR.
Consolidated Precision Products is a sand casting foundry that serves the aerospace, commercial, and military markets. CPP's vision is to drive operational excellence while investing in new technologies.
We were looking to accurately and quickly analyze our casting during their process cycles. We wanted to increase overall quality and enable scalable, repeatable workflow that will keep our business ahead of curve and exceeding customer expectations. We chose Creaform's QBAR for speed and accuracy. It offered very fast and accurate scanning capability, utilizing Metrascan 3DR to capture all surface data simultaneously on even the most complex convoluted surface areas. Now that QBAR is part of our process, we can identify very quickly the non-conformances in our castings. We scan the casting, then we best fit it to a nominal model. We see if there is non-conformance, then we repair it or move it to the next process. Working with Creaform application engineer was great. They are helping our company with a turnkey solution for programming multiple parts to QBAR. The tangible results are we identify the non-conforming castings, we eliminate escapes, and meet and exceed our customer expectations.
The QBAR will help CPP's mission by allowing us to dive into other markets, increase our market share globally, and increase our customer satisfaction with our existing legacy customers.
Installing Q-Bar is significant because we are moving to a new cutting-edge technology and preparing for the future.
Okay, in conclusion, when choosing the right technology, a manufacturing company should look for either a handheld or automated 3D scanners that can scan parts with complex geometry and any surface, any finish without preparation. A manufacturing company should remember that taking advantage of the speed of 3D scanning with or without quality control resources to operate the machine will increase the amount of information captured, helping them to take better decisions faster. If automation is considered, as you saw in the demonstration, programming a robot is more accessible than ever. Finally, we feel very strongly that doing a financial justification exercise of automation should be done prior technical validation. Once you start discussing technical, it is usually really hard to go back to financial before having invested a lot of time and money. Automation should be considered if it makes sense financially first. One important takeaway that we did not discuss today that might interest you is that putting a system on robot automatically increase precisions, or also known as repeatability. And this is something that you need to keep in mind if repeatability is actually highly valuable for your organization. Creaform is a technological leader, not a follower. Creaform was founded because other measurement technology defined as portable was simply not suitable for shop floor environments. We aim to tackle our clients' most difficult challenges and are eager to push the envelope. Our company is headquartered in Lévis, Quebec. We have now 15 offices in 12 different countries to meet the demands of our global customers with local service, language skills, and spares inventory. Let's move to the Q&A period. There were already some questions that came in during the presentation, but you can still ask questions in the GoToWebinar panel. We will do our best to answer all of your questions. Let's jump right in with a question. Let me open up the question tab here. Okay, so can you put a 3D scanner on a collaborative robot? Absolutely, yes. When you think about operational simplicity, we've shown you how simple it is to deploy and use a 3D scanning CMM. But if you're going to use a collaborative robot, then the deployment phase just become easier. So that is definitely a possibility. Second question, what is the accuracy specification of a 3D scanning CMM? So for the system I've shown you today, the accuracy on a sphere diameter, for example, will be 25 micron. That's a maximum dev ISO certified, and the accuracy in the entire working volume of the system, for example, distance between two features, the accuracy you're going to get on that will be 78 microns. Scanning tools are often time consuming to calibrate. We have a question here. I guess your question is how long does it take to calibrate the system? I guess my best answer for that would be to visit our YouTube channel. We have a playlist for automated quality control system. We have a specific video on how to calibrate the C-Track, how to calibrate the MetraScan. You will see the entire process and how it is fully automated. Other question, what are the costs and how often should these be calibrated and how long is out of service? So as far as the cost of the entire system, it would depend, but we had a question earlier about collaborative robots. So if you think of putting a collaborative robot with Metroscan 3DR and deploy that solution, if you include everything, it's probably going to be around 250,000. If you think of a full Q-bar type of product, which can take parts up to 3 meters and is fully optimized for cycle time and everything, you're probably going to be more between $400,000, $500,000. As far as the calibration frequency, the system itself has a 5 days period that will require to recalibrate. The system itself comes, and I didn't get too much into the details of the Metroscan 3DR, the C-Track. That could be a great subject for next episode. Well, we have tools in the software to help us to prevent not only for shop floor vibration, but also temperature changes, things that usually would trigger the need for recalibration of other devices. You can install on your fixture a scale bar, and the system will use it to compensate for slow temperature change over time, helping you to reduce the frequent or the need to frequent recalibration. I hope I answer correctly. I noticed all part scan were a small size. If they were larger part, 10, 20 feet with multiple feature and additional component. With this, okay, so yes, in this demonstration, we had a small part. I would say that if you look at a product like the Q-Bar, for example, the sweet spot of that product would be between 1.5 up to 3 meter parts. As far as meaning going a larger part than that, the C-Track itself has a 16 cubic meter working volume, so you can fit a pretty large part in it. Plus you can combine multiple C-Tracks together to extend the volume and have up to 4 C-Tracks connected together. Now, if you are going to think of a very large part, 10, 20 feet part, 20 feet will not fit in a Q-bar, 10 feet would, however. But if you're thinking of a 20 feet part, you can definitely think of a custom made either a handheld setup and move your C-Track along your parts, just like you would do leapfrog, but instead of measuring features while you're leapfrogging, you would just look at targets along your parts to extend your volume. If you would be doing that with an automated system, you could think of a system mounted on an external linear axis. In our case right now, we had an external axis, but it was a rotary axis, but you could also think of having a custom-made setup with a robot on a linear axis. Wow, a lot of questions. I'm trying to read at the same time. Did you develop a station that can scan 3 meter by 1 meter by 1 meter casting? Yes, that's and probably a little bit higher than that and wider than that actually. I'm not sure if you're talking about an automated system or a manual system, but if your application would be a 3 meter by 1 meter by 1 meter system, you can do that, like I said, with a handheld device and move your C-Track around if it doesn't fit inside the complete C-Track volume. If you're thinking of having an automated system, we would have the Q-Bar product itself would do your parts. As far as the weight, 1,500 kilogram, 3,000 kilogram casting. Really, it's more into the technical detail of a solution. But again, if you're thinking of a Q bar, that will be a little bit overweight. We would have to go and build for you a custom-made setup, helping you with a system integrator. Maybe you already have a system integrator in-house for robotic system, and we could use a turntable with much heavier payload. Can you scan smaller parts, 75 centimeter by 75 centimeter by 75 centimeter? Absolutely. We can scan them with the MetraScan. We can scan them with our other portable 3D scanners. We've shown you the MetraScan 3DR today. We have scanners that are optimized. I don't want to say optimized, that have a sweet spot for smaller parts. If you look at the NDScan product line, yes, it requires to put targets on the part, but the portability is extreme. The scanner is smaller. It's a less heavy ecosystem compared to a C-Track, but those are auto-positioned 3D scanners. So if it depends where you are in your manufacturing process. Are you looking to control prototypes or one-off, and you just want to measure one part in a very high mix, low volume type of application? Or are you looking to do some quality control in production? This is also a good way to look at different 3D scanners out there to choose the right one for your application. I hope I answer everything. I wanna thank you all for those great questions. If I missed some question, I'm sorry. We will look at everything and come back for sure. Be assured that I'll be happy to reach out and follow up on your question. In case you arrived late or you had sound problem, this webinar is being recorded, and it will be available shortly. You will receive a link in the upcoming days. We'll try to send it tomorrow. We'll see. Thank you all for attending our webinar. You have been a great and very attentive audience. I can feel it. One last thing, at the end of the webinar, there will be 2 quick questions that are going to pop up. They will help us for future webinars to choose topics that are interesting and relevant for you. So please just take a moment to fill those questions. There will also be a comment tab where you can comment on this webinar, ask other questions in case you didn't have time to do so. Again, thank you very much. Really appreciate you guys being here. Have a good day.